Liking this video will help this channel to grow. So please go ahead and give this video a like. In today's lesson, we will be concluding with section 3, which focuses on similar volumes. Just to remind you that each section includes a worksheet for independent practice, which can be found in the description of each video. Now guys, with that being said, let's get into the lesson. So on the back of the two previous lessons that we've done on linear scale factors and area scale factors, now we're focused on volume scale factors and finding similar volumes. So if the length scale factor is x and the area scale factor is x squared, what then is the volume scale factor? By now I think you're getting into the rhythm of this, so I hope that you said the volume scale factor would be x cubed. Amazing. So to calculate our volume scale factor, we must first of all find our length scale factor or linear scale factor and then cube it, since volume is calculated using cubed units, or we could say cubic units. So let's put this to the test. So we're given two shapes here, A and B, 5 and 15 centimeters respectively. Shape A and B are mathematically similar. What is the volume scale factor from A to B? So first of all, I need to find my linear scale factor. By that, I'm going to do 15 divided by 5. 15 divided by 5 is equal to 3. So therefore, my volume scale factor will be 3 cubed, which means 3 times 3 times 3. So 3 times 3 times 3 is 27. So therefore, the volume of shape B will be 27 times larger than the volume of shape A. Beautiful. Now, we're going to be calculating using our scale factors. So below are two similar pentagonal prisms. We're given A, we've got one side of A, which is 3 and 9 for B. We're told that the volume of prism A is 15 centimeters cubed. We're asked to work out the volume of prism B. So remember, first of all, we have to find our linear scale factor and then use that by squaring to find the volume scale factor. So linear scale factor is equal to 9 divided by 3. So 9 divided by 3 is equal to 3. So therefore, my volume scale factor would be equal to 3 cubed, and 3 cubed, we've just done that, is 27. So therefore, if I know volume A is 15 centimeters cubed, then volume B is equal to the volume of A, which is 15 centimeters cubed, multiplied by the volume scale factor, which is 27. So I'm just going to put that in my calculator. So I need to do 15 multiplied by 27, and that gets me to 405 centimeters cubed. Remember, volume is measured in cubic units. So I've got to make sure that I do not mix up my area, which is squared unit, with my volume, which is cubic unit. Amazing. So we finished one example there. So let's go to do this one that involves just a decimal here. So prism A and B are similar. So the volume of prism A is 7 centimeters cubed. We underline that. Work out the volume of prism B. So again, we're going to go ahead. We know we have to first of all find our linear scale factor. So linear scale factor is equal to 7.8 divided by 2.6. These are the matching pairs. So 7.8 divided by 2.6 also gets us to 3. And then the volume scale factor, again, is 3 cubed, which is 27. So I'm going from small to large, so also need to multiply. So therefore, volume B is equal to 7 multiplied by 27, which is my volume scale factor. So just put that in our calculator, 27 times by 7, and that gets me to 189 centimeters cubed. 3 marks, guys. Not difficult at all. Finding my linear, finding my volume scale factor, and then I look if I'm going from small to large, I multiply. If I was going from large to small, I would have divided them. Beautiful. So next example. So the prisms below are mathematically similar. We're asked to work out the volume of the smaller prism. So this time we're doing it the other way around, but the principle remained the same. So we look and we notice that the volume of the large one is 512 centimeters cubed. We know the linear side is 12 centimeters, and for the linear for the small one is 3 centimeters. So I need to use those two to work out the linear scale factor first of all. So linear scale factor is equal to 12 divided by 3. So 12 divided by 3 is 4. So the volume scale factor is equal to 4 cubed, which means 4 times 4 times 4. So 4 times 4 is 16, and 16 times by 4 is 64. So the scale factor, volume scale factor, is 64. So note this time around, I'm trying to find the smaller area, smaller volume. So I need to divide. So smaller volume is equal to the volume of the large one, which is 512, divided by the volume scale factor, which is equal to 64. So I'm just going to put that in. So 512 divided by 64, and that's exactly 8 centimeters cubed. So I know I'm correct. I expect to get a smaller answer since I'm going from the large shape to the small shape. Absolutely brilliant. So now we go to our final example. So we're told here that prisms A and B are similar. The cross sections are shaded. Now the cross section of A is 32 centimeters squared. We do not know the cross section of prism B, but we know the length. The area of the cross section of prism A is 32, which is the shaded region here. The length of the prism B is 18, which we can see on the larger shape. The volume of prism A to the volume of prism B is 8 to 27. Work out the volume of prism B. So first of all, we need to remind ourselves of the formula for the volume of a prism. So let's write that down and then deal with our ratios. So volume of prism, and it's any prism at all. So volume of prism is equal to the cross-sectional area, which I'm just going to call CSA. So it's the area of the cross-section, which is the shaded bit, multiplied by the length, which is from the front to the back of the prism. So in order for me to find the volume of prism B, I first of all need to find the cross-sectional area. So now it's time for us to write our ratios down. So the volume of A to the volume of B, we were told, is 8 to 27. So again, in order for us to find the area scale factor, we need to find the linear scale factor. So because we're given the ratios in terms of the volumes, we now need to find the cube root of these two. So I'm going to do the cube root of 8 and the cube root of 27, and that will get me my linear ratios. So the cube root of 8 is 2 and the cube root of 27 is 3. So this is the linear. So I'm just going to put L there. Now I need to find the area by squaring the linear. So let's go. So we're going to do 2 squared and 3 squared. So 2 squared is 4 and 3 squared is 9. So the area ratios is 4 to 9. Now I can use that to help me to find the area of prism B, the cross-sectional area. So A is 32, so I'm just going to line up my 32 here. So how do I get from 4 to 32? 4 times by 8. So if this multiply by 8, I now need to multiply 9 by 8 as well. 9 times 8 gives me 72. So the cross-sectional area of B is 72. So I'm just going to put that on my diagram. So that's 72 centimeters squared. Now, last thing to do is to just find the volume using the formula I wrote down at the beginning. So the cross-sectional area of prism B is equal to 72. So the volume is equal to cross-section 72 centimeters squared multiplied by the length, which is 18 centimeters. So just going to put 72 times by 18 in my calculator. So 72 multiplied by 18, that's 1,296. Now centimeters squared multiplied by centimeter gives me centimeters cubed, and of course I know I have to end in cubic units. So you can see the progression there. I was given the ratio of the volume. I had to cube root that to get the ratios of the linear components and then square the linear to get the area. Now that I know the area ratios, I can find out the scale factor that takes me from 4 to 32, which was 8, and then do that scaling up by 8 to get the 72 for the cross section of prism B, and then just substitute that in the formula for the volume of a prism. So you can see it is very important that we watch the video on linear, watch the one on area if we haven't, and this would be so much more easier for you to navigate. So now guys, what we're going to do is to look at our key takeaways. So first of all, we talked about the fact that if we have a length scale factor of x, the area scale factor would be x squared and the volume scale factor would be x cubed. Brilliant. Now we talked about the fact that if we wanted to find the volume scale factor, we needed to find the linear scale factor first of all and then cube it, because it will be multiplied by itself 3 times in order to get the volume scale factor. Now once we know that, we can navigate any question. So if you wanted to find something about area and you knew the volume scale factor, you would cube root that to get the linear and then square that for the area. So you can navigate your way through volume, area, and linear. Absolutely brilliant. Guys, as usual, I'm so proud of you. So proud of you for investing in yourself. And if you haven't yet liked the video, which I know most of you already have, then you need to do that now. Also, please share with someone just in case they've missed it. Also, remember, we are on TikTok where we do additional questions that we haven't looked at in the lesson. And also, there will be additional questions that you can access for your independent practice in the description of the video, and the answer is also given so you can self-assess your work. So guys, thank you so much for watching.